Hi, in this video we're going to discuss about solving a differential equation by using the methods of separation of variables. Alright, and this differential equation require you to using the concept of separation of variable, or we can say that this is a differential equation with separable variable. Okay, let's look at this differential equation. Right, this is the first order differential equation. So we will try to separate the variable according to x and y to right hand side and the left hand side. Usually we will arrange such that the y will be on the left hand side and the x is on the right hand side, right? So we try to simplify first, okay, before we separate the variable here, because we can't see anything that we can move on. So ex y, right? Okay, so but this it consists of e power of negative y and e power of negative 2x minus y. So what I'm going to do is I'm going to rewrite this index form into negative 2x multiplied with e to the power of negative y, right? So you must have some knowledge about algebra. So why I can rewrite this as this? Because as you multiply, you can add up the index because the base is the same, right? So you add up negative 2x minus y. So I separate the variable. Okay, now I'm going to factorize the e power of negative y out from the right hand side, so of the bracket, so negative y. So inside I have 1 plus with e to the power of negative 2x, right? E power negative y, is a common factor I taken out, so it's 1 plus e power of negative 2x. So now it's getting easier for me to separate the variable, right? Separate the variable. So now follow. Okay, y and dy I'm going to leave it on the left hand side. This is a term with y. So and for this is also the same, e power of negative y as you multiply, right? These two concepts multiply. So you're going to divide both sides by e to the power of negative y, right? Divide by e to the power of negative means that, okay, y dy divide by e to the power of negative y, right? E power of negative y. For these three, I'm going to put them together on the left hand side, right? You divide. And whereas for ex dx, so after you're moving this, go to the left hand side, you still have 1 plus e power of negative 2x, right? And ex multiply with y, right? So I'm going to divide by ex. For this right hand side, I'm going to divide by ex, alright? Divided by ex. I'm going to move these two, go to the right hand side. So multiply here, I divide over there. So, and there is a dx here, right? So you bring it up, you become dx. So I have using the method of separation of variable, right? I have separate the variable. Okay, if you see that the y dy, I stay here, saying here, everything that have y, I try to take it out and factorize and bring it over to the left hand side, right? By divide e power of negative y. So whereas dx, I will go to the right hand side and I'm going to divide ex here, so that the ex will go into the right hand side. So now I have already separate the variable. So and I put the integral. I want to integrate both sides now because I have already separate the variable. So okay, now it's your job for determine the integration techniques of integration. As e power of negative y, you can bring up become ey dy, right? So whereas for this e power of x, so it's just a one term on the denominator, so I can rewrite to be 1 over ex, right? Plus with e to the power of negative 2x over with ex. Everything dx, right? 1 over ex plus with e power of negative 2x over e to the power of x. So for this part, you know that if you're familiar, you can look at this. This is actually, we're going to apply the integration by parts. Whereas for this, you just apply normal formula for exponent, right? So e power of negative 2x, I'm going to minus with x. Do you know why I'm doing that? Because there's division, same base. I take the index minus the index here. So I have e to the power of negative 3x dx, right? So later on, okay, I rewrite this one again. So now I'm going to solving this by using techniques. For the left hand side here, I'm going to apply the integration by part. So what is your u? As integration by part, you need u and you need a dv, right? So u, you always choose the polynomial and the ey dy as your exponent for dv, right? U, this is your u, and the remaining will be your dv. So for this, we differentiate du dy equals to 1. So du is dy. As you integrate this, integrate 1 dv, you're getting v. Integrate ey, you're getting ey, right? So now I have listed out all the important information. So now I start to integrate. Start to integrate this side. So let's see. Alright, okay. So for this side, left hand side, we're going to using the formula of integration by part, uv minus we integrate of v du, right? So we just putting all the variable here, y as your u, y, v, ey, minus bit v, ey, right? V is ey. So du will be dy, right? So replacing this. So and integrate e power of negative x plus with e to the power of negative 3x dx. So now you can see that you can differentiate, you can integrate easily, right? Because y, ey, this is already integrate ey, if you have ey, right? Integrate e power of negative x, you were getting e power of negative x divided by negative 1, right? So, and for this, e power of negative 3x divided by negative 3. Divided by negative 3. Then plus a constant after all the integration have completed. So, then rewriting this, you have y, you can factor out the ey if you want, right, to make it nicer, ey, right? So you have y minus 1 equals to negative e to the power of negative x, negative positive negative e to the power of negative 3x plus c as the general solution for this differential equation. Alright, so I will giving more examples in the same video. Alright, let's continue with these examples. So I always want students to assume my video lesson as exercises, okay? Doing the exercises and trying to solve it and look at the solution, alright? Look at how I present my solution. And maybe you have a better solution than mine. Alright, let's look at this. So sine 3x dx 2y cos cube 3x dy is equal to 0. So always remember that you try to see whether this you can separate the variable or not. Okay. So 2y. Okay, I'm going to rearrange this cube 3x dy as we have dy for this case, and the x, the term with x, I'm going to moving to the right hand side. Right. It becomes negative sine 3x dx. So the first step here, what I'm going to do is I'm going to bring this go to the right hand side. I just want to tell you that I'm going to group all the x on the right hand side and all the y variable on the left hand side. So now the remaining here we have 2y dy, right? So 2y dy going to stay on the left hand side, right? Going to stay on the left hand side, whereas the cos cube I'm going to multiply, or we said we divide both sides by cos cube. It will become negative sine 3x divided by cos cube 3x dx. I do division. As I divide the cos cube on the left hand side, this will be eliminated, right? You are getting 1. And for here, you are getting a over with cos cube 3x. So after you have complete, you can see that you have already separate the variable. You have already using the method of separation of variable to solving this differential equation. So let's just putting an integral to solve. You want to solve it, right? You want to solve it. So, so now we have to consider the suitable techniques, as this is a basic integration rule, right? This is basic integration rule, and for this we try to modify. Okay, we can always try to modify to make sure that we can integrate, right? We can integrate. So there are many ways. You can using u as a cos 3x, right? Or sine over cos. So I will using the sine 3x over with cos 3x multiply with 1 over cos square 3x. This is okay, right? And another way of doing this is using substitution method, where you let the u to be cos 3x. It's the same, okay? And this is also will be the same. So, but this I try to using the tangent. So I bring out the negative. So sine over cos will be tangent 3x. Right? Sine over cos will be tangent 3x. And 1 over cos square will be secant square 3x dx. And this is also okay, right? Because why? Differentiate tangent, you're getting secant square. So you also can using the substitution method or any formula that's suitable, right? You can know that u to be tangent 3x. Just take u to be tangent 3x. As you know that I'm doing substitution method, so du dx, differentiate tangent. So you are getting secant square 3x, right? Differentiate 3x, you're getting 3. So then I divide du by 3, where I bring the dx go over that side, secant square 3x dx, right? See carefully what am I doing, right? I choosing u as tangent. Why I choosing u as tangent instead of secant square? Because differentiate tangent, I getting secant square, which is exactly inside there, so that I can replace it with du. Okay, so now du over 3, the secant square 3x dx can be replaced by du over 3. So it means that negative integrate as tangent already become u, right? U. And this whole thing can replace with du over 3. It's become simpler, right? So okay, together we integrate both of this. So integrate 2y dy, right? 2y dy. So you are getting 2y to the power of 2, 1 plus 1 divided by 2, right? On the left hand side. Whereas for this, I can actually bring it out the constant 1 over 3, negative 1 over 3, integrate u du, right? And for this, it will be getting negative 1 over 3, right? Negative 1 over 3, integrate u, you will have u to the power of 2 divided by 2, right? Plus 1 divided by 1 plus 1. So add with c after you complete the integral. So later on, complete it. So by writing y squared equals to negative 1 over 2, 3, 3 to 6, right? Negative 1 over 6. So what is your u? You should know that u will be tangent 3x, right? Tangent 3x to the power of 2, or we said tangent square 3x plus c. So this will be the solution for this differential equation, right? By using the concept of separation of variables. Alright, that's all for this video, and I'm hoping you that you really understand the concept of separation of variables.